Hey, Faith. How are you today?
I'm good.
Oh, good. You're going to actually talk to me. Yay. I'll go over this worksheet. Did you have other questions or are you just wanting to go over the worksheet?
I just needed to go over it.
Okay, great. Well, I'm just going to start working through them and I'll do the whole worksheet with you as long as you want me to. If you start to run out of time, you can say, Miss Sparks, will you just please skip ahead to the next section and I'll try to go back and fill them in. Just to kind of give you a heads up, I was a little late to math lab because the worksheet took me about 40 minutes. And I probably wouldn't have assigned this many problems if I would have known that. Because I'm thinking if it took me 40 minutes, it might take, I think that's right. I think I started it like right at 10 after 11, and then I started doing math labs. So maybe it was 30 minutes. I don't know, somewhere between 30 and 40. So, but we'll just start and you let me know how long you have because I'll stay with you till we get it done. Okay?
Okay, thank you.
No problem. And I know that the answers were there, but that doesn't, I don't know if Miss Stone actually posted. She might have been quicker than me. I accidentally posted with the answers on there. But I know the answers are on there, but that doesn't really help you, get to where you need to go. So basically what I do, the very first thing, and I kind of have this particular method that I just walk through these steps every single time. First thing I do is find the distance, the common distance or the difference between them. Hang on just a second. I don't know why it's not writing. Hold on. I apologize. I'm very sorry.
It's okay.
Landon made some fixes to the Google Chromebook. And it kind of took away some of my capacities to do things. So it's taken me a little bit longer to do some stuff, but he's just trying to protect us all from like viruses and stuff. Because yesterday I opened something up and it looked like something was coming after, like something was trying to attach to a file. So I'm glad he's doing it, but I'm like, it's taken me a minute longer today. Okay, to find the common difference, you're basically, what I tell everybody is to always subtract that second term or subtract the first term from the second. So you'll write the second and then subtract the first, which is going to give you a difference here of 200. And then I just kind of try to take a quick glance and make sure that each consecutive term after that is in fact going up by that same difference, because sometimes you're not going to be dealing, like once you get introduced to other types of sequences and series, you're not always going to be dealing with an arithmetic. So this kind of gives you an idea of what type of sequence or series you're dealing with. So now I know that the difference is 200. So I'll take a quick glance at that 430 and kind of confirm in my mind the difference between 230 and 430 is in fact 200. So I know I can now with assurance say that the difference, it's an arithmetic sequence and the difference is 200. And that's the very first step. So D equals 200. Now, to get the explicit formula, basically, you're going to hear this word or this term referred to as formula, explicit formula, or even sometimes, I believe our book will call this the rule, writing a rule for it. That's all the same exact syntax or verbiage for that same thing. That's what it means. So what we're going to do is take what we know, and the formula is A sub n, which the n just means any number in this particular sequence that we're dealing with. And then we'll plug in, because we'll plug in that first term, which is 30, plus your difference, which is 200, and then n minus 1. And then you just kind of work it algebraically. 30 plus 200 n minus 200, distributing that 200 through the parentheses. Now I'm going to combine like terms, which I've got 30 minus 200. So that's 170, negative 170. And then I'm just going to bring down my 200. So my explicit formula for this is 200n minus 170. And I probably should have written, she wrote for y'all all of what the standard formula looks like, right? Maybe I better just rewrite that at the top so that you'll know. That standard formula, if you kind of want to write this at the very top of your page, always looks like this. AN equals A sub 1, which stands for that first term, plus the difference times n minus 1, which that means whatever term that you're looking for, you're actually, what that means is the term that you're looking for, you're going to be multiplying the distance times the one that was before it. So that's basically how they came up with the formula. But the basic formula that we're going to be working with every time is A sub n equals A sub 1 plus the distance times n minus 1. So that's what you're going to be working with every time. But the answer for number 1 thus far is A sub n equals 200n minus 170. And the difference, the common difference, is 200. Now, in order to do this last piece that we need to work on, that 52nd term, A sub 52 equals, what we'll do is plug in 52 for the n. To get our answer. And when you plug all of that in the calculator, you will get 10 or 10,230, however you want to say it. So the common difference is 200. The rule or the explicit formula is A sub n equals 200n minus 170. And the 52nd term of that sequence is 10,230. Hey, Adriana.
Hi.
How are you?
I'm good.
I was checking back just to see if anybody else had joined. But I'm just basically going to walk through this worksheet and do the whole thing. As long as y'all hang out with me, I'll keep doing it. Okay?
I have to go soon, but there's a YouTube link, right?
Yes, ma'am. There is.
Awesome.
And since I know that you have to go fairly soon, sometimes I had a little trouble getting it the other day. One of my students is really good, and he actually showed me how to go get it. So I'll make myself a note to make sure that I email you with the exact link.
Okay, thank you.
Okay?
Yes, thank you.
Not a problem. But I'm just going to keep working.
Yeah, sure.
So for number 2, the very first thing that you want to do is look for that common difference. And you just kind of want to always make sure, like I say, that when you're finding that common difference is that each one, once you find it from the first one, that you keep, you just double check that third term to make sure that it is in fact an arithmetic sequence. But the common difference, to find that, you're going to take that second term and subtract the first term. So now I have a negative 30 minus a minus 27, which is the equivalent of negative 30 plus 27. So my common difference is negative 3. And so just kind of double checking that. Is that what happens when I go from the second term to the third term? And it is, because when I go from negative 30, if I were to add a negative 3 to that, I would in fact get a negative 33. So the next thing that I'm going to do is plug in what I know into that standard formula that we talked about earlier, which is a sub n equals a sub 1 plus the difference times n minus 1. So you're just going to continue plugging in what you know. And we're trying to find that explicit formula, so we're not going to specify a sub n at this point. We're going to plug in negative 27, because that's our first term, plus, and then we've got a negative 3 times n minus 1. Negative 27, distribute that negative 3, gives me negative 3n. A negative 3 times a negative 1 is plus 3. So now I have a sub n, combined like terms, negative 27 plus 3 is going to give me a negative 24. And then I bring down my multiplier, which is negative 3n minus 24. And you'll see, I think the answer sheet actually has the constant going first. That's not how I write it, just because I feel pretty trained to always put my variables first. So I always start with my variable and end with my constant. But this is the explicit equation, or the rule, the explicit formula, however you want to express it. For number 2 is a sub n equals negative 3n minus 24. Now, basically, to find that 52nd term, I will plug in (52) for my n. Plug that in my calculator, and I'm going to get negative 180.
Answer, but I did something different.
Okay, you did get that answer, but you did something different. What did you do?
I don't see what Miss Stone showed us yesterday. Put negative 27 plus 51 times negative 30.
Oh, I got you. Yes. Yes. And you can do it that way. I understand exactly what you're saying now. And you can, but since we're actually trying to find the explicit formula anyway, I know later on when we do the sequences, I will actually be doing a little bit more of that. But I see what you're saying. She did a sub 52 equals, then she plugged in that first term, plus she did the common difference, and then she plugged in 51 right here, because that technically is n minus 1, because your n here is the 52. So n minus 1 is 51. And you can do that. It doesn't really matter, but since you had to find the explicit formula anyway, because that was part of the instructions, I just went ahead and plugged it in. But that either way is absolutely fine, as long as you understand that when you're plugging in that that difference, and when the difference between actually plugging in the 52 into the rule and plugging in 51 when you're just using the first term and the difference. Does that make sense?
Yes, that does.
Okay. All right. Well, and so later on, when we're working with summations, I think it's the last 4 problems on this worksheet, I actually do use that method since I'm not, first of all, required to find the rule or the explicit formula. It's just that for when I am asked to find the rule, it's just easier to kind of keep it with the 52. But it doesn't make any difference how you, obviously you get the same thing. What's really good about it is that understanding the difference between n and n minus 1 and knowing when to use it. So that's awesome that you understand all of that. So that's great. That's perfect. Because that really, gives a deeper understanding of sequences and series. So great. So I can kind of work it a variety of ways here in MathLab to make sure that we're hitting both of those, and making sure that we're understanding everything that we can possibly about the sequence and series. I want to keep my formula there, but move down. All right. So let's look at number 3. Once again, we want to find our common difference. So I've got 36 minus 30 equals 6. So my common difference for this one is going to be D equals 6. And now, if I wanted to kind of work this out of order and go ahead and find the 52nd term, I know that A sub 52 equals A1, which is 30, because that's my first term, plus, I apologize, my common difference, which is 6, times what's n minus 1? 51. So then you would just plug that into your calculator, which I have all of mine worked the other way, so bear with me just 1 minute. $336. So is that how you did it, Faith?
Yes, ma'am.
Okay. All right. Okay, so the 52nd term is 336. And now we'll work on the explicit formula. And to get that, you would plug in what we know, which is the first term, which is 30, plus 6 times n minus 1. So we'll distribute and then 30 minus 6 is 24. So that's your explicit formula for this one. Adriana, if you're still with us, do you have a preference? Like, which way would you do it? Would you just plug in the 51, or would you get the explicit formula or the rule first and then plug in 52? Do you have a preference?
I usually just find the rule and then plug in 52.
Okay. All right.
I worked ahead, so I went ahead and finished all 4 of them, and I think I've been doing them correctly, so.
Okay, good. I love to hear that. This is just one of those, I think this is one of those exercises that just takes practice, So, Faith, have you got them all worked? And would you all rather me just show you the answers for these and jump ahead to the next section, or do you like me working them all out? Your call.
I understand this section.
Okay. All right. So I think what I'm going to do then is go ahead and go to number 5. And This is one of those where we're supposed to find the 52nd term and the rule. So in order to do that, what I did was I realized I would plug in what I know, which I'm kind of using that same premise that we were using earlier. I plug in what I know, that 2,222. And then I'm going to plug in A1 plus my difference. And then my n minus 1 equals 12 minus 1, which equals 11. So I'm going to put in 11 right there. So I get 2,222 equals A1 plus 2,200. Then I'm going to subtract 2,200 from both sides, and I get 22 equals A1. And then now I have I'm going to work on my explicit formula by plugging in my A1 term and my difference. I'm going to distribute. And then negative 200 or 22 minus 200 is 178. So this is my explicit formula for this one. And now what I would do is plug in 52 into the formula that I just found. Was she doing it that way in class yesterday, Faith? On these?
Yes.
Okay. Once I plug all of that into my calculator, it's a whopping number. It's 10,222. Did you all work ahead and get that?
Yes.
Okay, good. How'd you do, Faith?
I got that.
Good. Y'all are doing good. Okay, so on this next one, you plug in what you know to the formula. And we know that 5,794 is the 30th term. And we know that the difference is 200. They're big on that 200 difference. And then n minus 1 is going to be 30 minus 1, which is going to be 29. No confusion about where I'm getting the 29, correct? Everybody's clear on that? And
Yes, ma'am.
and then then we'll 200 times 29 is 5,800. And then subtract 5,800 from both sides, and you get negative 6 equals A1. Then you'll plug that back into the formula to get your rule. Negative 6 plus 200 times n minus 1. Distribute. And then negative 6 minus 200 is going to be negative 206. So that's your explicit formula for that one. So then you would plug in 52 for n. And you would get 10,400 minus 206. And then your final number is 10,194 for A52. Did y'all get that?
Yes,
Yeah,
ma'am.
Okay. Do y'all want me to keep working some of these or move to the next section?
I actually have to go.
Okay.
So yeah, I gotta go.
Oh, okay. Faith, do you want me to do a few more of these or move to the next section? And I'll talk to you later, Adriana. Have a good day.
Could you move on to the next section, please?
I absolutely can.
Thank you.
No problem.
Yeah, these next ones I'm kind of confused on.
Oh, okay. All right. Well, they are a little bit different, but and do you have the answers? Did she attach the answer key?
No, she didn't.
Oh, okay. Well, I was going to say as we work through some of these, then we can go through the answer key just to make sure that you, as you're working them, you'll have the right ones. How's that?
Thank
Yep. Okay, no problem. Okay. On these, the thing that I want to point out, the very first four of these, so even though the sections are not divided very differently, the big thing, the first four of these, you'll notice that the bottom limit, and when I say the bottom limit, that's the I or the N or whatever designated variable that there is at the bottom of the summation symbol. That bottom limit, you always want to watch that. That's the key thing. And when it's 1, the formula is going to be really easy. When it's a different number, there's a little calculation and a little trick I'm going to show you. But since it's 1, not really a big deal for this. But you'll notice in the book they had S sub n was the formula. And our video was slightly different than that. I mean, it still says S sub n, but it means the sum of all of the numbers in this sequence. And this bottom limit is 1 and the top is 14. So it's saying, okay, the first 14 numbers in this sequence, I want the sum of those numbers. So just the trick that you're going to use every time is going to be 14 minus 1 equals 13, and then add the 1 back in to know the number of digits within that set. That's why I said if the bottom number is 1, it's kind of a no-brainer. So that n, the formula looks like this. Okay, that's the formula. So you're looking for the value of the first number, the value of the last number or the last number in the set, and that's all divided by 2. Okay? And this n right here is the number of numbers in the set. So the actual whatever's in there. And this will make more sense as we walk through it. So the number of numbers in this set is going to be 14. Okay? And then inside the parentheses is going to be the value of the first number. So the value of the first number that we find is going to be 10 times 1, because that's the first number, the I, minus 6, which 10 times 1 is 10, minus 6 is 4. So that this first number at the top is going to be 4. The second number at the top is going to be 10. Plug in that 14 minus 6. So that's 140 minus 6, which equals 134. So that's going to be 134. And then that's all divided by 2. The video actually took that divided by 2 and put it under the 14, but it doesn't really make too much difference where you divide by 2. You just need to know at some point you divide by 2. So you've got here 138. This part right here, this is 138 divided by 2, which is 69. Is that right? Yes, 69. So then you've got 14 times 69, which should give you 966. So the sum of the first 14 numbers in the sequence that has the rule 10i minus 6 is 966. All right, let's do the next one, and hopefully as we work through some of these, it will continue to become, clearer.
Understand the ones.
Okay, good. I'm sorry?
The ones when you plug it in.
I'm sorry, say that again.
Sorry. I think it's that where it says like I n equals 1. It's the ones that don't understand.
Oh, okay. So it's more of like when it's down here, like number 13?
Yes.
When it starts with a different number?
Yes, ma'am.
Okay. All right, great. I'm going to actually start with 14 and then move back to 13. And the reason why is because because this is a more of a countable type thing that will hopefully make it clear. Okay, what it's saying is there is a sequence that follows the rule 10n minus 6. And within that sequence, I want to find out what the sum of the values are from the second term to the 8th term. So if I were to actually count that out, that would be 2, 3, 4, 5, 6, 7, 8. So how many terms is that? 1, 2, 3, 4, 5, 6, 7, right? So that would be the value of the second term. It would be the value of the third term, the value of the fourth term, the value of the fifth, value of the sixth, value of the seventh, and value of the eighth. Whatever the value is, all of those added together is going to be the sum. So what I usually do as my trick to finding that out, since that's a total of 7 things that I'm going to be adding, if you'll look at 8, the top number minus the bottom number, that's going to give you 6. If I always add 1 to that, I should come up with the exact number of what's in the set. Does that make sense?
Mm-hmm.
Okay. So that's how you find, that's why I wanted to start with this one, because I wouldn't be able to, if I do 37 minus 3, it would take me a long time to write those 35 spaces. So that's why I wanted to start with one that was a little more quantitative that I could write down. So now when I plug in my information, if the formula is the sum of n numbers equals the number of numbers times the value of the first one plus the value of the last one divided by 2. Then this number right here for this one is going to be 7, because we figured out that 8 minus 2 equals 6 plus 1 more is 7. There's 7 things in this set. There's 7 values in this set. So now what we'll do is find the value of that first number that they're asking about, which the first number they're asking about is the second one in the set. So 10 times 2 minus 6 equals 20 minus 6, which is 14, right? And then what's the value of the 8th term that follows this rule? That's going to be, oh, whoops, my bad. 10 times 8 is 80 minus 6 is 74. So I'm going to add 14 and 74. Which is 88 divided by 2 is 44. And 7 times 44 is 308. So the sum of the values in the sequence starting at the second one, going all the way to the 8th that follows the rule 10n minus 6 is 308. Is that a little better?
Yes, ma'am. That makes so much more sense.
Oh, okay. Okay. Well, let's, just to be on the safe side, let's do, let's go back and do number 13. Because those values are really outside ones that we can, that we obviously can, make tick marks on the screen for. So we've got, so my summation is going to be the number 37 minus 3 equals 34 plus 1 equals 35. So the number of values that are in this set is 35. That's the number of values in the set. Now I want to find the actual value of the third one, which is going to be 10 times 3 minus 1 equals. So 30 minus 1 equals 29. And now what's the value of the 37th term in this sequence? That's going to be 370 minus 1, which is 369. So I'm going to have 29 plus 369, all divided by 2. So then that's going to be 398 divided by 2 here. And 398 divided by 2 is 199. And 35 times 199 is the sum, 6,965. Is that a little clearer?
Mm-hmm.
Okay, great. Did you want me to do any more of those, or you want me to skip down to the other ones?
Could you skip down to number 17?
Yes, ma'am.
Thank you.
Not a problem. Glad to do it. On ones like 17, 18, 19, and 20, one of the things that you're going to want to do is find the common difference so that you can just get the value of that last term, because you need the first and the last term in order to find those, to define those values in the formula, because the formula is S sub n, the number of terms, times the value of the first plus the value of the last, all divided by 2. Okay, so we know the first term. So far, we're pretty good. We know the first term is 22. We know the number of terms is 13, so that's kind of cool. We don't have to use our trick to find that. But we don't know the value of that 13th term. So the value of the 13th term is going to be a sub 13 equals the first term. And then what was the difference? I didn't calculate that. My apologies. 32 minus 22 equals 10. So my difference is 10. I'm just going to confirm that by checking. 32, 42, 52. Yes, it looks like it's actually going up by 10. So then I'm going to do 10. And what is the n minus 1 for this one? It's 12. So then I can find out the value of the 13th term is going to be 142. And then I'm going to plug that in over here. And then 22 plus 142 is 164 divided by 2. And then that's going to be multiplied by 13. So 164 divided by 2 is 82. And 13 times 82 is 1,066. Okay. Should I do one more?
Yes, please.
Okay. Was that confusing or is it a little better?
No, it's making sense now.
Okay, good. Good. I think just trying to do a few of these and put all of the things together that we've learned is really the key. All right. So the first thing that we want to do is find the difference to make sure we have that, because we kind of want to put together our formula. And the difference is from 9 minus 5 is 4. So the difference for this particular one is 4. And I'm going to put my formula over here and start plugging in things that I know. I know the number of terms is 8. I know the value of the first term is 5. I don't know the value of that 8th term yet. So I'm going to plug that in. 5 plus a sub 8 is 5, which is my first term, plus my difference times n minus 1. And n minus 1 is going to be 8 minus 1, which is 7. So 5 plus 28, which is 32. No, 33. Oh, Miss Sparks can't add. So we've got 38 over 2. 8 times 38 over 2, which that's going to be 8 times 19. And 8 times 19 is 152. Would you like me to work 19 and 20?
Could you do just 20, please?
I'm sorry, say that again. You broke up just a little bit at the end. Do one more?
Just 20, please.
I'm sorry, that it broke up, Faith.
Just 20?
Just 20?
Yes.
Absolutely. I sure can. Okay. So the difference for this one, I'm going up by 2, so the difference is 2. All right. So I know the number of terms is 18. So I'm going to go ahead and start writing in the things that I know. I've got the number of terms, which is n. And then I know my first term is 12. And now I want to find the value of that 18th term. So A 18 equals 12 plus the difference, which is 2, times n minus 1 is 17. So 12 plus 34 is going to be 46. So I'm going to plug in 46 because that's the value of the last term. All of that goes over 2. And 12 plus 46 is 58 over 2. And 58 divided by 2 is 29. And 18 times 29 is 522. Was there another one that you would like me to do on the worksheet? Did you want me to go back up and do some of the other, like 15, 16, that don't start with, like, so the bottom limit is not 1?
I'm good.
Okay. And I will tell you another common thing for SAT and ACT is that bottom limit will be 0. And so you got to be cautious there.
So what do you do if it's 0?
You would still use our little trick that you and I talked about during this. And if that, let me erase this. If that bottom number was 0 and the top number, let's see. It's crazy because it's going to come out bigger than that top. So I am kind of glad we're talking about it. So let's just, and my sigmas are really, really ugly. So I apologize. Let's just say the bottom number is 0 and that top limit was 20. And then let's just say, let's just use this same formula that was here. 10 n minus 16. Okay. Then you would still use that little trick that we talked about where you do 20 minus 0 equals 20 plus 1 equals 21. So there's actually 21 values in that set. Okay, so the summation would look like this. 21. And then the value of that first number where you plug in 0, right? So you would plug in 0 for the top value. And then, so 10 times 0 minus 16. So that's going to give you a negative 16 on the top for that first value. And the value for 20 is going to be 10 times 20, which is 200 minus 16, which is, what is that? I should know this. 184.
184.
Divided by 2, and then minus 16, there's going to be 168. Divided by 2 is 80. So you have 21 times 84. So the summation for that would be 1,764. So the key difference, though, is the fact that your number was 21, because this bottom number is 0. So there's actually, because even though it's weird, what it's basically saying, that bottom limit, it's containing the value 0 within the set, and the value of 0 in that set is negative 16. So you would literally have 21 values that are being added together. So if I said, okay, Faith, I want you to add up the first 21 terms in a set beginning with like 0 to 20, you would actually be adding 21 items.
Oh, okay.
Does that make sense?
Uh-huh.
Okay. So you're still going to kind of use that little trick that I gave you, where you're taking the top limit, subtracting the bottom limit, and then adding 1 to that difference. You'll use that all of the time. I'm just letting you know that that it seems like that bottom limit a lot of times on standardized testing is 0. So that's why I kind of wanted to alert you to that.
Okay.
So it doesn't trip you up if you ever see it. Do you have any other questions?
No, I think I'm good. Thank you so much
Oh,
for
not a
helping
problem.
me.
Oh, not a problem. Thank you so much for coming to Math Lab. I really appreciate it. It's better than sitting here by myself. I hope you have a blessed day.
You too. Thank you so much, Miss Sparks.
No problem. Take care. Okay.